Hello, so can you hear me all and the screen is shared?
Yes, ma'am.
Okay. So the thing is, today we are first learn binary search tree, then we go for graph theory. So binary search tree, already we have learned tree. Tree have multiple branches, but each binary tree should have either zero branch or one branch and at most two branch. Binary search tree is also a special type of binary tree. Now I have whose left child node always smaller than the parent and whose right child node always greater than the parent. When we are going to form the binary search tree, we have to take in our mind that for each node, if it is supposed to be a root, then its left child will be lesser than it in number and its right child will be greater than in number. So তোমরা আমাকে বলবে যে so how can we construct the binary tree? So it is a question of here that construct a binary tree for the following key value. 30, 20 binary search tree. 30, 20, 40, 25, 15, 35, 12, 5, 14, 37. So suppose you have to take 30 as the root. So you have taken, one second. So you have 30 as the root. Then you take 20. 20 is lesser than 30 or greater than 30, lesser than 30. So 20 you have placed here. Then 40, which is greater than 30. You have placed 40 here. Then 25, then go for the next node because it is a binary tree. Binary search tree is a type of binary tree and binary search tree is a type of binary tree which also...
Ma'am, your screen is not coming.
Cannot coming?
Your screen is not coming.
For others
Computer
too?
No, sir. No, ma'am. It's okay. It's fine.
Then please you check your connection. I already zoomed it. Okay.
Ma'am, it's totally fine.
Construct a binary search tree for the following key value: 30, 20, 40, 20, 15, 35, 12, 5, 14, 37. Now, তোমরা নিজেরাই বলো প্রত্যেকটা নোডে they must have not more than two child. So now after 20 and 40, we are having the value of 25 and 15. So where this 25 and 15 will go? For already I have told that if all these nodes are taken as parent node, then their child will follow the order that the left child will be lesser than the root corresponding parent and the right child will be the greater than the corresponding parent. So the next number is 15 and 25 and we place like that. If I place 15, we know it is less than 20, so we put it at the left of 20. And we know that 25 is greater than 20, so we have turned it here at the right. Now the next two nodes after 25 and 15, there are 35 and 12. So how you are placing them? Suppose 35. Suppose you put, so there are two possibilities. 35 can be the right child of 25 or 35 can be the left child of 40. So which one is accepted? 35 cannot be the right child of 25. Why? Because see, if you see this 30, the main root, all the roots who are in the left subtree of this, all the nodes which are in the left subtree of this root should have the value less than 30. And all the nodes which are present in the right subtree of this tree, so of this root, they will have the greater value of 35. So 30. So if you place 25 right child 35, then it will invalid the rule, because then the right subtree will contain a value 35 which will greater than 30. So it is not allowed. So we are placing to the next suitable position. So we have taken the 40's left part. Okay. Now 5. 35, then 12 and 5. See where we can place 12. You tell me where the 12 will be placed. বলো, ছবি তো পুরোটা দেখা যাচ্ছে না। 12 where it will be placed? 12. Already the tree has formed with this notes: 30 child, 20 right child, 40, 20 left child, 15 right child, 25, 40 don't have any right child, the left child is 35. Now tell me the next comma 12, where it will be placed?
15 left side.
Very good. 15 left side. And then the 5?
12 left side.
Very good. তাহলে দেখো জিনিসটা 14 আমি ওঠাচ্ছি না, তোমাদেরকেই জিজ্ঞেস করছি। 14 where should be it?
12 right child.
12 right.
Not 12 right 12 right side or 14 left side. দাঁড়া একটা জিনিস, 12 right you have told, na? 14 for 12 right. Yes, very good. And 37?
37, 35 right side.
Now you see the whole picture as you told. Okay, first 30, then 20. 20 is lesser than 30, so it placed here. 40, it is greater than 40, so it will be placed here. Then 15 and 25. So one of them is greater than 20 and one of them is less than 20. But you cannot place 15 and 25 in this shell. Why? Because all the right nodes are greater than 30 and all the left nodes are less than 30. Okay, so then the next comma is 35. We cannot put it at the right side of 25 for the same reason, so we put it at the left of 40. Then come 37 ta last. Then come 12, so we placed at the left of 15. Then come 5, we placed it at the left of 5. Then come 14. So 14 is lesser than 15, but the lesser position is not vacated. 14 is not greater than 15, so it cannot be placed here, but it is greater than 12, so we have placed there. Finally 37. 37 should go to the right subtree and it will be at the right of the 35. And now you will be asked, eta note ache I have shared already, the pre-order, in-order and post-order traversal of this tree. এটা নিয়ে আজকে আমি সময় নষ্ট করব না, because already last day we have discussed, I have sent you notes. So, and in that note, that note, this page is there. Otherwise, you can take a screenshot from this computer. You can take, see this is the binary search tree. Take one screenshot in your computer or laptop or phone, whatever you are using. And for this page, you also take a screenshot. And these are the traversal. Understood? বোঝা গেছে? So what type of questions you, acha, now you tell me that if you ask, instead of binary search tree, please create one binary tree, then what will happen? Then you, এখন তো এখানে লেখা যাবে না, আমি just বলছি শোনো, then no comparison will be there, because the comparison is only for the search tree, not for the normal binary tree. So you ask that you make a binary tree of it. So what will happen? Plus you take 30. It should have one left child, one right child. That will be 20 and 40. Then 20 will have one left child and right child. That will be 25 and 15. Then we'll go here. There is 40. 40 have a left child and right child. That will be 35 and 12. Now the 4 levels are come. So তোমাকে কি করতে হবে? You have to create one node and place the left and right value. Then again here you place the left and right value. The way it is coming, the way it is coming, then 20, 40, then next level 25, 15, 35, 12. Then the next level in for 25 there will be 5 and 14, and for 15 there will be only left child 37. So তখন we will not check how the values are lesser than this or greater than this. How we will just fill the value? First you fill this node, then left node, then right node. Then you take this node, then left node and right node. Then you take this node, left node and right node. Then you take this node, left node and right node. Then this left node, right node, then this left node, right node, and so on. যেরকম আসছে ওরকম পরপর left and right করে করে বসিয়ে দাও. No order to be maintained. Only the sequence in there coming that you should maintain. Okay? Understood?
Yes, ma'am.
Okay. Then closing, and I am sharing another PDF. Okay? That is graph theory. Is the screen is visible to all?
Yes, ma'am.
Yes, ma'am.
Yes.
Someone is telling that his screen is not visible. Now you can see the screen.
Yes, ma'am.
Okay. So this note I will share in the group because today is our last class. One class is from now 11 a.m. to 12 p.m. Another is from 2 p.m. to 3 p.m. That may be started some late because I will be outside. So আমি বলে দেবো এই টাইমটা লগ ইন করতে, that time you will log in. Half an hour, 40 minutes may be late. Okay. So this graph theory totally I will cover in these 2 classes. Now graph theory. So we have covered the linear data structure as much class provided with linear data structure. Please, whoever entered the class, give your attendance. Now, we have completed the linear data structures who are stack queue linked list, and we have completed one, not completed, it is not possible to complete everything, but we have just explained what is tree. 2 trees only I can explain, that are binary tree and binary search tree. The traversals, pre-order, post-order, in-order, both are same for both. The way you traverse the binary tree, the same way you have to traverse the binary search tree. Only the formation of binary tree and binary search tree is different. Now that is also a nonlinear data structure, and today we are going for another nonlinear data structure, which is a graph. So graph, if you represent a graph with a set, G, then G will have two things, V and E. V means vertices, E means edges. So you see how many vertices are there? V1, V2, V3, V4, V5. So there are 5 vertices. And how many edges are there? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. It is a closed graph. Okay, that is for spanning tree. Okay. See how many vertices are given? V1, V2, V3, V4, V5. It is a closed graph, so all the vertices are connected to each other in any way. Graph is not fixed. With whatever the picture you will be given as a graph, your action will be according to that picture. Now here the G equals to vertices and edges. It is a graph. So for graph consists of a set of vertices and a set of edges. Each edge or arc is a graph specified by a pair of vertices. এটাও একটা graph. This is also a graph. This is also a graph. All edges also a graph. V is a is this out of this V and E. V is a non-empty finite set of vertices and E is a set of pair of vertices and can be represented as VG and EG. What is undirected graph? A graph is said to be undirected if the pair of vertices representing any edge is unordered. Unordered means, suppose see, I have not placed any arrow. So the path from V1 to V5 is possible. At the same time, V5 to V1 is also possible. So if I not placing any arrow. So what is directed graph? Directed graph, if I produce some arrows over here. See the arrow signs. So we can travel V4 to V3 but cannot travel V3 to V4. Again we can travel V5 to V4 but can't travel V4 to V5. So for V4 to V5 there we have a route. We first have to go to V3, then we have to go to V5 because arrows is in that way. So a graph is said to be directed if the pair of vertices representing any edge is ordered. If the direction is mentioned for moving from one vertex to another, thus the pair V1, V2, V1 is the tail and V2 is the head and V2, V1 will be different. So এটা আমি আগেও বললাম এখনো বললাম. What are adjacent vertices? A vertex is said to be adjacent to another vertex if there is an edge between the two vertices. So for this for undirected graph, V1 is having the adjacent vertices V2, V3, V5 because both three of them are connected directly to V1. For V2, the edges are V1 and V3. They are directly connected to V2. And V3, they have 4 edges that is directly connected to V3. And V5, they have 3 edges which are directly connected to V5. Now for directed graph, adjacents are like that. If there is V1 is adjacent of V5, if and only if V5
Ma'am?
arrow towards
Ma'am?
directed,
Ma'am, someone wants to join the class.
so a graph for if it is a connected graph, then the outgoing if V5 আচ্ছা আমাকে এমনি বোঝাতে দাও V5 is the node, then its adjacent are whom? V1 and V4. Okay, this is not adjacent. Why? Because the arrow is coming here, not going there. For V2 you tell me the adjacents.
V3, ma'am. V3.
Only V3. For V1,
V2,
V2.
for V4,
V3.
okay. So the number of adjacent, a number of outgoing edges from the node is the uh, degree of that vertex. Path. A path, one vertex to another vertex, is the sequence of vertices each adjacent to the next. The length of a path is the number of edges to it. A cycle is a path in which first and last vertices are same. So it is a cyclic path. See, এরম ভাবে এটা আবার ওখানেই এসে জয়েন হয়ে গেছে, but it is not directed. So this is one actually the V1. It is also a cyclic graph. This one is a, because it has create some cycle. It's closed anyway. See, path. A path from one vertex to another vertex is the sequence of vertices each adjacent to the next. Path মানে কি? Suppose you want to go from V1 to V5. What will be the path? From V1 you can come to V2. From V2 you can come to V3. Now from V3 you cannot come to V5 because the arrow is here. So from V3 you have to come V4, then you have to come V5. So for V1 to V5, what is the path? V1, V2, V3, V4, V5. And there is another path. And from V5 to V1, what is the path? There is this circular path. V5 to V1. Is there any other path to V1? V5 থেকে কি in any other way we can reach V1?
No, ma'am.
Yes, because no options are there. So, path তোমরা বুঝতে পারলে কাকে বলে? A graph is said to be connected if there exists a path from any vertex to any other vertex. See, this is maybe a connected graph. V1 to V2 we can reach, to V3 we can reach, to V4 we can reach, to V5 we can reach. V2 to V3 we can reach, V4 we can reach, V5 we can reach, and V1 we can reach. V3 to V4 we can reach, V5 we can reach, V1 we can reach. From V3, can we reach V2? Yes. From V3 we have to go V4, then V5, then V1, then V2. And for V5, V1 we can reach, V2 we can reach, V3 we can reach, V4 we can reach. Understood? So it is a connected graph if there exists a path from any of the vertex to any other vertex. তার মানে এর সবকটা vertex এর মধ্যে vertex will be connected to all the rest of the vertex. Strongly connected graph. A directed graph is a strongly connected graph. This one is a strongly connected graph. If there is a directed path from any vertex to any other vertex. Directed path. তাহলে যখন গ্রাফে কোনো ডিরেকশন থাকছে না, that is, but we can reach from one node to any other node, then it is called a connected graph. But if the graph is having direction and each node should have a path to all other nodes, then it is called a strongly connected graph. বোঝা গেল এই অবধি? Weighted graph. A graph in which a number is associated with the arc is called weighted graph or network. Okay, weighted graph আর কিচ্ছু নেই when each of the edge is contain and number which is called weight. If each of the edge is assigned with a weight, with the edge, then that assigned weight is the weight of the corresponding edge. And if each of the edge of a graph is associated with a weight or a number, then the graph is called the weighted of graph. দেখো degree of vertex টা কি বলছে? The number of edges adjacent to the vertex is called the degree to the vertex. The number of edges adjacent to the vertex is called the degree of the vertex. But adjacency should have a rule. If from one node to other node no direction is given, then it is not adjacent. And suppose era degree ke they are divided in two parts. The number of edges coming in the vertex is called the in degree, and the number of edges which are coming out from the vertex is called the out degree. Representation of graph eta porikhay deয় korte. Suppose you are given one graph like this, and you have to find out the adjacency matrix and adjacency least. This is the way for represent.
Zoom little bit.
Tell me.
Zoom.
Okay.
Sir, you can also zoom in on your screen.
Okay. And so there are two types of representation of graph. এটা শিখে নাও, এটা করতে দেয় অনেক সময়. You will be given one graph and you will ask to find out the adjacency matrix of the graph. So I explain how this adjacency are being calculated. How many nodes are there? 5. So you make a matrix over here. The matrix will have 5 rows called V1, V2, V3, V4, V5, and 5 columns V1, V2, V3, V4, V5. Now, what will happen? You first check V1 and V1. Is there any edge between V1 and V1? No. They are same node, so it will be 0. If there any edge from V1 to V2, yes, 1. From V1 to V3, yes, 1. From V1 to V4, tell me.
No edge.
No.
No, ma'am, no, zeroই হবে.
তো কি বলছে? The adjacency matrix for a graph G equals to VE with n vertices is an n into n matrix such that each cell number Aij will be 1 if there is an edge from Vi to Vj, and Aij equals to 0 if there is no such edge. So why this V4 is 0 we can understood, and V5 is 1. Is V1 to V5 there is one edge. So it is required to have a direct edge. Not a direct edge, means directed or may not be directed, but there should have a edge between V1 and V5. Now you go for V2 and V1. Yes, that is there. See the 0 parts. V2, no edge, 0. V2 to V4, it is 0. V2 to V5, it is also 0. Can you say me? V2 to V4, no edge. V2 to V5, no edge. So this is 0. আমার মনে হয় now you can complete the rest of the matrix. You can see the matrix. Check it. Check it fast.
It's okay, madam.
Okay. Now the adjacency least. It is also same. In this representation, we use the linked structure. Linked structure stores all the vertices in a list, and for each vertex, we have a linked list of its adjacent vertices. We have make a linked list representation. Here it is, see, it is a printing mistake. It will be vertex 1, vertex 2, vertex 3, vertex 4, vertex 5. Now, vertex 1, it is the vertex 1 node, it is the vertex 2 node, it is the vertex 3 node, and vertex 4 node, and vertex 5 node. Now, you have to find out in vertex 1 to which edges they are connected. Vertex 1 is connected to V2, V3, V5. Let me check. V2, V3, V5. Vertex 2 you see is connected to V1 and V3. So it is V1 and V3. Vertex 3, V2, V1, V5, V4. V2, V1, V5, V4. Then every of the node is last node is connected to null. Okay, last node is only a representation, nothing else. Finally, V4, V3, V5, and for V5, this 3. So this is the adjacency list. Understood? For each vertex, you have to find out those nets, those nodes which are only directly connected to this vertex 1. So V1, V3, V5 is directly connected to vertex 1. V1 and V3 are directly connected to vertex 2. V1, V2, V4, V5 are directly connected to vertex 3. And V3 and V5 are directly connected to step 4. And V1, V3, V4 are directly connected to step 5. Okay. Before starting DFS and BFS, we are going for the class spanning tree. Spanning tree. A spanning tree of a graph is a subset which contain all the nodes n of the graph connected by n minus number of edges and should not form any cycle. So it is a subgraph which contain all the vertices or all the nodes of the graph, and if there will be n nodes, then there will be n minus 1 edges and it will not form any cycle. To construct a spanning tree for a graph, take any vertex V as an initial partial tree and add edges one by one so that each edge joins a new vertex to the partial tree. In general, if there are n vertices in the graph, who is entering the class now? Tanmay Bhattacharya, are you in the class? Give your attendance, you are too late. To construct a spanning tree for a graph, take any vertex V as an initial partial tree and add edges. If there are n vertices in the graph, we shall construct a spanning tree with n minus 1 steps. N minus 1 edges are need to be added. For weighted graph, we need to construct a spanning tree with minimal cost. So, if from a graph, the graph should have multiple vertices, multiple edges. But if we try to form a spanning tree of the graph, then it is a cost-effective method because spanning tree will contain all the nodes which are present in the graph itself, but it will not contain all the edges and it will not form a cycle. Say this graph is a cycled graph. All the edges are connected. No open up is there. Now you form the spanning tree. One graph may have multiple spanning trees. See, G, B, A, C, D, E, H, F. It is one spanning tree. Another spanning tree. A, B, C, D, F, G, A, E, H. বুঝতে পারছো? A, B, C, D, E, F, G, H. This graph is also contain all the vertices. A, B, C, D, E, F, G, H. This graph is also contain all the vertices, but not all the edges. And now you count the vertices. 1, 2, 3, 4, 5, 6, 7, 8. So there would be how many edges? If there are 8 vertices, there will be 7 edges. Count the edges. 1, 2, 3, 4, 5, 6, 7. For this graph also there are 8 nodes and edges will be 7. 1, 2, 3, 4, 5, 6, 7. Now ask if you have any questions.
And that means there is no any rule for this construct a spanning
No,
tree.
no, no. A graph may have multiple spanning tree. The rule is that all the nodes to be present there, all the edges not to be present there. The number of edges should be one less than the number of nodes, and there should not be any cycle over there. These are the rules for spanning tree, and one graph may have multiple spanning tree. There are two algorithms which are there, Kruskal algo and Prim's algo, which will help you to find out the spanning tree. So let's start one algo, and one is distrust shortest path problem. So we have 5 things to do. 5 things we have to learn that are Kruskal algo, Prim's algo to find the minimum spanning tree. And so see, multiple spanning trees are there. Suppose if these edges are weighted, and then which suppose there are 2 spanning tree এবং এখানে প্রত্যেকটা এজের গায়ে একটা করে weight দেওয়া আছে, কেউ 10, কেউ 20, কেউ 30, and else all the edges are weighted. So when you are taking the edges from here, the weights also be associated here. So tell me of this which tree, spanning tree, which one is cost effective? এখানে
Ma'am, I am just asking that what is the minimum cost? What is minimum cost?
Yes, minimum cost means the weights will be there. You have to count the total weight of the tree. You also have to count the total weight of the tree. Why? This will be not same. These are different because here AB age is there, but AE age is not here, but AE age is here. So you have to count the total value of the graph. Means suppose here you have 10 plus 20 plus 30 plus 40, 50, 60, 70. But suppose you are given 20 plus 20 plus 20 plus 20 plus 20 plus 20 plus 20. So whose cost will be greater? This one's cost will be lesser. So this is the minimal spanning tree. You have to calculate the weighted sum of the graph. So you have to compare the weighted sum, the spanning tree, which is having the minimum cost, it will be the accepted minimal spanning tree. And this concept actually we apply on the traveling salesman problem. A traveling salesman may have multiple cities to visit with multiple distances in kilometer. So he will find the minimal cost spanning tree, that all the cities he has to traverse, but with less distance. Suppose instead of width, the distances are given there. So he has to find all the spanning trees, and he will see that which spanning tree is the cost effective. That is the minimum cost. He will follow next day that path. That path.
That means lesser the cost is the minimal cost.
Yes, that is the minimal spanning tree, and that will be the cost effective. তুমি cost বাড়ছো এটা চাইছো না cost কমবে এটা চাইবে না cost কমবে. So there are like tree traversal, that is pre-order, post-order, and in-order. Graph is also having 2 traversal, breadth first search and depth first search. I have 2 examples. I will explain you what is breadth first search and what is depth first search. But the thing is that some algorithms are also there. Once you understand the breadth first search and depth first search, then in 2 ways the question are coming. You will be given a graph and you will ask to do the DFS on it. You will be given a graph and asked to do a DFS on it. So that I will give you that sort of examples I will give you. But the algorithm you have to read your own. It is for your purpose. If the question paper asks instead of DFS sums, sometime illogically they will ask for the algorithm. Then you will write the algorithm. And if you can't write the algorithm, then I will suggest you what I will tell that I will show you a graph, and I will tell you to find out the DFS. It is very easy. So you can also give that example with the steps if you, for you, it is difficult to remember the algorithm. Then we also grade the mark. যদি অ্যালগরিদম মুখস্থ থাকে লিখে দেবে মার্কস পাবে, আদারওয়াইজ যে
Sometime in question paper,
বলো
ma'am, sometime in question paper, there is a question, write an algorithm and explain with a intermediate step. Then what is the intermediate step there?
these are the intermediate steps. I mean, not come in this section. Step 1, step 2, step 3, step 4, step 5. These are the intermediate steps to found the final DFS. এটা আমি শেখাবো next class. Okay. And algorithm is algorithm. Okay, algorithm is not having in intermediate steps. These are all the 12 steps of algorithm. But this is the normal algorithm. But if you they ask for intermediate steps, then you have to yourself you have to form a graph, and you will show them how you are traversing the graph using the DFS algorithm, and that will be the intermediate steps. Okay. এইটা আমি শেখাবো কিভাবে যাচ্ছ। আমি এসছি যখন ডেপথ ফার্স্ট সার্চটাই করাই। So in graph we have to know the DFS, BFS, Kruskal, Prims and Distrust shortest path algorithm. So first we are traversing the graph, that is depth first search. Suppose এটা একটা পরীক্ষায় আসে এরকম, you have given this graph V1, V2, V1, V2, V4, V5, V6, V7, V8, V3. V1, V2, V3, V4, V5, V6, V8, V7. The connections are already given. Now what are the intermediate steps? To depth first search. Depth first search মানে কি? You have to traverse the tree according to the final depth, not according to the breadth. You have to travel the tree according to the depth, to the length or the extent, how much the nodes can visit. দেখো, visit V1, it is the root. Who are the adjacent nodes of the V1? V2? বলো adjacent nodes of V1 কারা?
V2, V8, V3.
Very good. V2, V8, V3 are the adjacent nodes. So from the 3 adjacent nodes, you have just chosen V2. Choose V2. This is the intermediate step 2. Choose V2. Now for V2, who are the adjacent nodes? V4, V5, and V4, V5, nothing else. You choose V4. তুমি বলবে কেন V5 সিলেক্ট করলাম না, এটা আলফা নিউমেরিক্যালি যেটা আগে আসছে, we will have to select that because it is, see, V1, this is a path, this is also a path. So we are first choosing V4 because alphanumerically it is previous one. V4. For V4, who are the adjacents? Tell me.
V8.
আর কিছু নেই?
V2.
So we cannot go, it is, we need backtracking, so we'll not backtrack. So we'll select V8.
V8.
So V1, V2, V4, V8. This path you have already created. Now from V8, who are the adjacents?
V5, V6, V7.
V4, V5, V6, V7, these are the adjacents, of which V4 is already visited. So you have to choose which one.
Ma'am, V1 or adjacent?
Yes, V1 is also adjacent, but yes, good. So when we are choosing V8, see, when we are choosing V8, we have choose V8 or as V2 already visited, and the adjacent nodes are কি কি বললাম? V4, V5, V1, V6, V7, of which of which V1 already visited, of which V1 already visited, V5 already visited, so sorry, V4 already visited, so this one, these two are visited, so this will be selected, V5, alphanumerically previous, V5 will be selected. Okay, after V5, what are the adjacents of V5? Tell me. V2, V4, V8,
V2, V8.
V2, V8.
all are visited, right? So this is
Yes.
final depth have come. See, the depth is here. তুমি কতটা ডেপথ বলো তো এই ট্রিটার কতটা ডেপথে নামলে? One, you have traveled to V2. From V2, you are traveled to V4. From V4, you have come to V8. From V8, you have traveled to V5. So you have no place to go from V5 because V2 is occupied, V8 is occupied. So what you have to do, you have to backtrack. So এই পুরো এই ট্রি এর ডেপথটা দেখো, গাছের ডেপথটা দেখো, V1, V2, V4, V8, V5. It is the depth. But from there you have no route. So you have to come back to the previous path. Okay, here. Now, when V1 is the root node, so who are the adjacents? V2, V8, V3. Now we have selected V2 and go from there to here. Now we are backtracking and come to the next node of V1. V1 is the adjacent node of V8. Now who are the adjacent? V4, V5, V6, V7. Whom you will choose? Tell me.
V6.
V6.
V6. So after backtracking, you choose V6. Now only one option is there. V6. What are the
V3.
Adjacents are V3, V3 and V8.
V8? V3 you have to choose, okay? Because no
Yes.
other options. From V3 you have to choose V7. No other options. Understood? So what is the DFS? Tell me. V1, V2, V4, V8, V5, V6, V3, V7. This is the DFS. V1, V2, V4, V8, V5. কি লিখেছি নিজেই বুঝতে পারছি না। দেখি
ম্যাম আমার একটা কোয়েশ্চেন আছে।
বলো।
ম্যাম আপনি বলছিলেন না যে আলফা নিউমেরিক্যালি আমরা যাব, তো অবভিয়াসলি ম্যাম V6 এর পর তো V7ই হয়, তাহলে V8 এর পর V7
না, কি বললে?
আমরা বলেছি, আপনি বলেছিলেন না যে আলফা নিউমেরিক্যালি যাব, যেমন ওখানে V2 এর পরে আমরা V4 এ গেলাম, V5 এ গেলাম না।
আচ্ছা, তুমি কোন নোট থেকে ধরছো?
আমি V6 এর পরে আমি ভাবছিলাম তাহলে V7 এ যাব।
না,
V8
আলফা নিউমেরিক্যালি তো 6 7 এর থেকে আগে, সেই জন্য তো আমি 6 এ গেলাম। আলফা নিউমেরিক্যালি তো হলো, তুমি V7 এ কেন যাবে? 8 এর যেমন 7 পরে, আলফা নিউমেরিক্যালি তো আচ্ছা, হ্যাঁ ঠিক বলেছো, দুটোই ওর থেকে ছোট, তো বেশি ছোট 6, তাই আমি এখানে গেলাম।
হ্যাঁ,
So you have to practice a lot. One graph will not clear your queries.
এখানে ম্যাম কনফিউজ হয়ে যাবে, এখানে কনফিউজ।
অনেক গ্রাফ আছে, না কনফিউজ হবে না। V8 এর মধ্যে V6 আছে আর V6 আছে, so
আচ্ছা,
both of them are alphanumerically lower than V8, so you have
হ্যাঁ
the lowest one because V5 এর পরে V6 আসে, তারপরে V7 আসে, তারপরে V8 আসে, so you have to choose here. But this is confusing. No issue. It is confusing, and the confusion can only be cleared by practicing too much. So this is the DFS. Only this much I will explain. Okay. Next class I will start from DFS, and then I will cover Kruskal algorithm, Prim's algorithm for creating minimum spanning tree, which are very important, and then we will go for the distrust shortest path problem. ওইটুকু যদি পড়ো তাহলে অনেক কোয়েশ্চেন পেয়ে যাবে MCS 21 এর জন্য। The graph theory is very good for collecting marks. আমি আমার একটা নোটস তো আমি তৈরি করেছি, এটাই দিয়ে দেবো, প্লাস কিছু ইয়ার কোয়েশ্চেন ফর গ্রাফ থিওরি I have solved. I will also give you those notes in the group. Okay. তাহলে নাও
ম্যাম একটা রিকোয়েস্ট আছে, আমি গ্রুপে বলতে চাইবো যে আমাদের আপনি যে গ্রুপে
হ্যাঁ
আপনার
আমি
নোটগুলো
বুঝতে
সেন্ড করছেন,
পেরেছি, হ্যাঁ
ওই
বুঝতে
গ্রুপটার একটু যদি লিঙ্কটা দিয়ে দেওয়া হয় ভালো হয়, তাহলে আমরা জয়েন করে যেতে পারবো।
শোনো, ওই গ্রুপটা ওরা, আমি একটা কথা বলছি, দাঁড়াও 1 মিনিট বলে দিচ্ছি আমি। হ্যাঁ, একটু ওয়েট করো, 2 মিনিটে হয়ে যাবে। ড্রেস পরে রেডি হও, বেরোবো এক্ষুনি। দাঁড়াও বলছি, আমি ওদিকটায় যাই আগে। আমি যেটা বলছিলাম, এই যে গ্রুপটা আমি বানিয়েছিলাম, এই গ্রুপটা আমি যেহেতু আমি তোমাদের 21 and 24 এর ক্লাসটা নিচ্ছিলাম, সেই জন্য আমি এই গ্রুপটা বানিয়েছিলাম। এই গ্রুপটা বানানোর আরেকটা কারণ আছে, যে এরপরে হয়তো আমাদের এই গ্লোবাল, 1 সেকেন্ড, স্টপিং, এরপরে হয়তো আমাদের গ্লোবাল ক্লাস